Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. So do you remember what were we discussing yesterday? I think we were discussing about the elimination reaction. In that elimination reaction is a E2 elimination reaction. In E2 elimination reaction, the evidences of E2 elimination reaction, and generally there are three evidences, means proof, to prove there is a E2 elimination reaction takes place or the elimination reaction occurs. Number one is a kinetic isotopic effect. What do you mean by the kinetic isotopic effect? With the help of suitable example, we have explained that concept. Second one is a element effect or the nature of living group. What type of the living group? If good living group, what is happening? Whether the E2 reaction goes or increasing or decreasing, that also we have learned with the help of suitable example. And third one, and what is that? Third one is third one is absence of hydrogen exchange. That is also we have learned with the help of suitable example. And then we arrive at the CH-5 elimination reaction, means the E2 elimination reaction, that is the CH-5 elimination reaction. What does it mean? What is CH-5 elimination reaction? Explain with suitable example. There we have learned the suitable example with and why it is, and we made as a CH-5 rule. What is that CH-5 rule? What is the definition of CH-5 elimination reaction? Or CH-5 rule? In an elimination reaction, more substituted alkene is obtained as a major product. That is called as the CH-5 rule. And most of the E2 reaction occur by the CH-5 rule. So that up till now we have learned this one, we have discussed this one. What we are going to learn today, let us look at to the board. What is written on the board? Justification of the CH-5 rule. Yesterday we have described the CH-5 rule with the suitable example. Now is what is that? Rule tells us that in an elimination reaction, more substituted alkene is obtained as a major product. That is the, in inverted comma we made this statement, more, and underline the more substituted alkene. More substituted alkene is a major product, and now with that is their statement. But here in the justification of CH-5 rule, justification means explanation. Why more substituted alkene is obtained as a major product in a CH-5 rule? What is the reason behind it? And that explanation is nothing but as a justification of the CH-5 rule. And there are this justification is explained, or what we can call it as a describe, or majorly there are the two factor contributing these two, and number one is called as a stability of the alkene. So this is a first contributing factor, which, because we are trying to justify the statement made by the CH-5, in an elimination reaction, more substituted alkene is obtained as a major product, and that major product, why we are getting as a major product, its justification, there are contributing as a contribution of two factor. One is the stability of the alkene. Number one, the stability of the alkene. Stability of the alkene. Stability of the alkene. This is a first contributing factor, that is the stability of the alkene. After the formation of the elimination product, are these products are stable or unstable? If it is stable, then and then we can say that this this is the product we are getting in a major, and this is a product we are getting in a minor percentage, or one of the product is a major, another one is a minor. In we have to measure in the percentage. How much percentage? Yesterday we have seen starting compound we have taken as a 2-bromobutane treated with the base generally as a sodium ethoxide. We got there are two kind of the beta hydrogen atom, and one then more products are formed. One is octane is a major, means 80% product we are getting, and second one is only as a just 20% minor product we are getting. But why one is a major and another one is a major? That is depending on the stability of the alkene, and what is and stability of the alkene is determined or measured in terms of heat of hydrogenation. And what does it mean, heat of hydrogenation? Across the carbon-carbon double bond, when we are adding as a H2 molecule, and whatever amount of the energy required to for this hydrogenation reaction is called as the stability of that alkene. If the hydrogenation, heat of hydrogenation, that energy is very less, then the stability of that alkene goes on increasing. If the energy is more, then stability ultimately is less. So remember, heat of hydrogenation means nothing but as a energy associated with the formation of that compound. If that energy is, and as we know that in case of a geometrical isomer, do you remember the geometrical isomer? That is a stereochemistry concept here in T.Y.B.Sc. You might have learned, or you might be quite familiar with this word, geometrical isomer. Geometrical isomer, there are the certain criteria for the geometrical isomer. There must be carbon-carbon double bond, and that olefin, that atom, there are A is equal to B, and A is not equal to B, and C is not equal, that D is not equal to E, then that type of the molecule shows as a geometrical isomer. Geometrical isomerism means what? There is a restriction of the rotation due to the presence of carbon-carbon double bond. That type of the isomer is termed as geometrical isomer in case of the cis and trans form. Again, cis form, in a geometrical isomer, trans isomer is generally more stable, generally found to be more stable than the cis isomer. Remember, in a geometry, trans isomer means what? Similar group are on the opposite side of the carbon-carbon double bond is termed as a cis isomer, and whereas cis isomer means similar group are on the same side of the carbon-carbon double bond is termed as a cis isomer. Trans isomer means what? Similar group are on the opposite side of the carbon-carbon double bond is termed as a trans isomer. And generally we have said trans isomer is generally found to be more stable than the cis isomer. Why? Because the energy associated with that trans isomer is less as compared to the cis, and therefore trans isomer is more stable than the cis isomer. And let us see here, if more substituted alkene is there, more substituted alkene, and more substituted alkene in that alkyl group exerts has a plus I inductive effect, and therefore that is increases. And before that, let us see hydrogenation energy, that hydrogen atom added across the carbon-carbon double bond, and that decided. For example, in case of this CH3, CH, to then CH double bond CH2, another one is a CH3, CH double bond CH, and the CH3. There are two isomers are there. Isomer means what? Having same molecular formula but different structures are known as isomers, and the phenomenon is known as isomerism are there. Now among these two, which one is more stable? This one should be the more stable, this one is less. According to as a CH-5 rule, what it said, that in an elimination reaction more substituted alkene is obtained as a major product, and therefore this is a disubstituted here, and here this one is a monosubstituted. If you find out its experimental energy, then what do you get? Heat of hydrogenation energy is found to be here in case of a 30.6 kilocalorie per mole, and this one having as a nearly approximate 26.6 kilocalorie per mole. The energy is less, and just now we made as a general statement regarding that the energy, heat of hydrogenation energy is less, the stability of that alkene is more there, and therefore this is there over there. Now let us look at a general reaction over here. General reaction, suppose we have here, let us look at as R2C double bond CR2 here. What is this? This is a tetrasubstituted. Remember, this is a tetrasubstituted alkene. Now I am writing here C2 double bond CHR, then again R CH double bond CHR, then again I am writing R C double bond, then CH2R2 CH2, and then R2CH, here make a correction over here, R2C double bond CH2 RCH double bond CHR, then RCH double bond CH2, and here CH2 double bond CH2. These are the sum of the alkene I am written specifically on the blackboard here. This one, if you look at here, this is only carbon-carbon double bond. Everywhere you will see here, there will be a carbon-carbon double bond. Now here means the alkyl group is there. This is a tetrasubstituted alkene. What about this? 2 are here and 1 are here, total is a 3. Therefore this is a trisubstituted alkene, and this is a 1,1 disubstituted alkene. This one is a 1,2 disubstituted alkene. This one is a monosubstituted alkene, and this one just as a alkene. Just one is a alkene. We can call it as what is that? Ethylene, right? Ethylene or the alkene. Now, just now we made that according to as a CH-5 rule. This is a tetrasubstituted. This one is more stable than this one, than this one, than this one, and than this one. This is the stability order of alkene. Stability order of alkene. Remember, they are the more stable towards this. Means tetrasubstituted is more stable as compared to as a trisubstituted. And what are the thing required? First one, it is a trisubstituted. Let us see why it one is a more stable or the reactive. Look at here, R group exerting, means this is a alkyl group. R is nothing but as a alkyl group that exerts as a plus I inductive effect, and plus I inductive effect increases the nucleophilicity of that carbon-carbon double bond. Hence its reactivity also goes on increasing due to the plus I inductive effect, and this is the one of the effect which contributing to increase the stability of that alkene. And the second factor, suppose if you see over here CH3 CH double bond CH2, and let us see another one CH3 CH double bond CH and the CH3. Now here I am inserting one of the CH2 group, so isomeric we can call it. CH3, CH2, CH double bond, CH2. Now among these two, which one is more stable? What do you think? This second one will be the most stable one, or more reactive one. This one is a less. Why? It is a monosubstituted, it is a disubstituted. Just now we have seen this is alkyl group that exerts as a plus I inductive effect, but there are two alkyl group, they exerting as a plus I inductive effect. The magnitude of plus I inductive effect in the second structure is a greater as compared to the first one, and therefore second one is a more stable as compared to the second structure. Second factor contributing over here, look at here, as we know that hyperconjugative effect. Inductive effect just now we have seen. Inductive effect means what? Polarization induced in adjacent bond. Due to the polarization in one bond is called as the inductive effect. There are two types of the inductive effect, plus I inductive effect and the minus I inductive effect. What are the group exerting as a plus I inductive effect? What are the group exerting as a minus I inductive effect? Everything we know that, but here plus I inductive effect exerting by the electron donating group, and whereas minus I inductive effect exerting or showing by the electron withdrawing group. Now second one is, you know that the resonance, what is that? Hyperconjugative. Do you remember the hyperconjugative effect? And you are quite familiar with this word hyperconjugative effect. Hyperconjugative effect is a modification of the resonance effect. And what is that resonance effect? Resonance effect is nothing but the redistribution of electron operating in unsaturated system via pi bond is known as a resonance effect. And resonance effect is further divided into two types. One is called as a plus R in resonance effect. Second one is known as a minus R resonance effect, or it is known as a mesomeric effect. That is the alternative name of that. And whatever structure, there are the certain rule to draw the resonating structure of that compound. And as we know that, and therefore hyperconjugative, whatever rules are there, because hyperconjugative effect is nothing but as a modification of the resonance effect, but it operating via sigma bond. That is the major difference between resonance effect and the hyperconjugative effect. In a resonance effect, the redistribution of electron operating in pi bond, but here the distribution of the electron is operating through sigma bond, there in a resonance effect through the pi bond. That is a major difference. Otherwise, the whatever rule for resonance effect, they are as it is used or apply in the hyperconjugative effect. And as we know that the number of resonance effect increases, the stability of that molecule goes on increasing. Same here, the hyperconjugative structure goes on increasing, the stability of that compound goes on increasing. Look at here, how do recognize the hyperconjugative effect? Look at here, CH double bond CH, one methyl group. This is a olefinic part. Adjacent carbon atom is termed as alpha, and whatever hydrogen atom bearing that carbon atom are known as alpha hydrogen atom. Look at here, 3 hydrogen atom. On this side, this is also as a alpha carbon atom, and therefore whatever hydrogen atom attached to those carbon atom they are termed as a alpha hydrogen atom. So total number of alpha hydrogen atom become as a 6 alpha hydrogen atom. How many structure, hyperconjugative structure you are going to get in the structure number second? There you are going to get as a 6 hyperconjugative structure. In the same way, in a structure number first, find out the alpha hydrogen atom. Here this is the adjacent carbon atom, therefore only as alpha hydrogen atom. Look at, only 2 hydrogen atoms are present. So there are 2 alpha hydrogen atom. It will give only 2 hyperconjugative structure. look at, there are 6, compare with therefore this is a more stable than this one, and therefore by using as these two factor, one is a resonance effect and another one is a hyperconjugative, that also supporting the why the tetrasubstituted alkene is a major than the tri or rest of the mono or di, like this. Understood? This is a first, that is stability of the alkene. Now is the second factor. What is the second factor? Lower the energy of activation. Second factor will be lower the energy of activation. This is another important factor which will be the major factor which contribute the justification of the CH-5 rule, and I am trying to explain the CH-5 rule. Second one is a lower energy of activation, lower energy of activation, right? Lower energy of activation, as we know that energy of activation is nothing but what we can call it as when the chemical reaction takes place, whatever transition states are formed, and during that process whatever energy is required, that energy is known as activation of energy. Lower the energy of activation, that increases the rate of formation of transition state over there. And now I am showing here the graphical representation, that is the energy profile diagram. Again, energy profile diagram means what? The graph is plotted potential energy versus reaction coordinate is known as energy profile diagram. Look at here, just now in case of the CH-5 rule we are talking about, what is happening at the initial, we are taking this type of the compound over there and we are getting as one of the another one, which one we will get as this type of the things over there, right? This is the energy profile diagram, and here on the y-axis, this is the y-axis, this will be the x-axis. On a y-axis there will be a potential energy. Potential energy goes on increasing from this side to this side. Now this is called as the reaction coordinate. Reaction coordinate or the progress of energy when that reaction goes into the conversion of that reactant into as a product. There is a middle one form as a transition state, and this is called as a first one. This is the EA1, you can call it as energy of activation. It is generally shown as a delta EA1, energy of activation, and this is called as a EA2, energy of activation. When the starting compound is the same, here CH3, CH, let me write here Br, then CH2 and the CH3, right? And I am using here is a base because these reactions are carried out in basic medium, and after the base is used, we are going to get the formation of the product over here. This is a CH2, double bond CH, CH2 and the CH3. One butene I am getting over there. Then the energy of activation is very high over there. When the formation of the two butene takes place here, CH3, then CH double bond CH, CH3, 2 butene. Look at this reaction carefully. What do you see? This is a 2 butene. The energy of activation is very low, means that formation of the transition state is very fast as compared to as above one, and therefore due to this reason in this case, now by knowing this low, one is the stability of the alkene, second is the lower energy of activation, now the CH-5 rule can be modified. The modified means modified definition of the CH-5 rule. Modified CH-5 rule. CH-5 rule. What is that modified CH rule? Now in the previous, the regular, what we can call it as the general statement of the CH rule, what is that? In an elimination reaction, more substituted alkene is obtained as a major product. This is the old definition. Now is a modified, means new definition. What is that definition? After studying these two factors, he modified the statement. What is that modified statement of CH rule? In an elimination reaction, now remember here, more stable alkene is obtained as a major product. Everything is the same, but there he used as a word. What is that word? The word is a more substituted alkene. But here the word, remember, more stable. It is a word is in the modified CH rule. Remember these two words. You focus on these two words, and then you can differentiate how the definition of that CHs are there. First means old definition for CH rule. In an elimination reaction, more substituted alkene is obtained as a major product, and in a modified definition, here remember, modified definition, in an elimination reaction, more stable alkene is obtained as a major product. So why he made? Because on the basis of this experimental fact, he modified his statement and given to us. So that is there. Now let me give one more example to why this one is getting as a major product. Another, let me give another example here. Let us see one more example here. CH, then Cl, then CH. Let me here Cl, then CH3. Just heat it in presence of sodium ethoxide. Right? So this is a product. This is the substrate. Let me clearly show that one. Here we have this one, right? Then CH2, CH, then Cl, CH3. This will be treated with sodium ethoxide in a OET. Sodium ethoxide. What will be the product you are going to get over here? The two products are possible. Look at here, chlorine attached to this carbon atom is termed as alpha, adjacent carbon are termed as a beta. This beta is different than this one, and therefore you can call it as a beta dash. You can clearly distinguish between these two beta because the environment around this proton are different than this one, and therefore they are definitely different, and therefore they gives rise to the two products. And among these two products, you have to tell me which one is a major and which one will be the minor. Now I am writing here the two products. Let us see here. Then CH double bond CH, CH3. I am writing as a first product over here. Another one, let us see here, CH2, then CH double bond CH2. Right? Two product I am writing. One is this one, another one is this one. What do you think, according to your opinion, whether first product, A product is a major or B product is a major? What do you think? Look at here. If you see according to as a CH rule, this is a disubstituted. Here it becomes as a monosubstituted. That's it. So simple. But here the examiner expect the another explanation here. What is that another explanation? In A, these carbon-carbon double bond are in a conjugation. Look at here, alternative carbon-carbon double bonds are there. That type of the organic molecules are more stable. Number of resonating structure goes on increasing. The stability of that molecule goes on increasing. So apply the same principle over here. There is a carbon-carbon double bond, single bond, double bond, single bond, and therefore it is a more stable. Means the double bond present in the conjugated with the benzene ring. This is a conjugated double bond. Conjugated double bond, and this is a non-conjugated double bond. Non-conjugated means that is a isolated system. This is a conjugated system. This is called as a conjugated system. Conjugated system, and this we can call it as a isolated system. An isolated system. While studying as a UV spectroscopy, we are going to learn why conjugated system is more stable than the isolated one. But here just remember, conjugated double bond, they are in the alternative, number of resonating structure goes on increasing, and hence this A is a more stable as compared to as a B. So that is the justification of the CH-5 rule. I think with this, let us complete this point over here, and remaining, that is a Hofmann elimination reaction. What is that? That we will see in the next lecture. Have a nice day. Thank you.